In this video, we're going to get a basic understanding of vectors. First, I've started with vector u, and I've written this in what's called component form. So what that means is -7 is a horizontal component, and 3 is the vertical component. So if I started at the origin, this would tell me to go left 7 and up 3. On a vector, where you start is called the initial point, and when you end is called the terminal point. Now the thing about vectors, they are not specific to location, they tell movement or displacement. So vector u could be written in many different places, and here I'm just showing how I can move it around and it's still the same vector. Now we want to look at vector v, which has a horizontal component of 2 and a vertical component of 6. Now once again, this vector can be moved around. Happen to have it start at the end of vector u. Now I'd like to look at adding two vectors. Since both of these are written in component form, you are allowed to combine like components. So the horizontal components are going to add together and the vertical components are going to add together. And I end up with -5, 9. So if I draw this from the origin, that says go left 5 and up 9, I happen to have the same terminal point as v did when it started at the end of u. And this is how vectors do add. They make a resultant, start at the initial point of the first vector and end at the terminal point of the last vector. Now I'd like to look at a different way vectors can be written, and this is with their magnitude and their direction. Magnitude is the length of the vector in this situation, and direction is the angle from the positive horizontal axis. So I'd like to be able to write this in component form so that if needed I can do arithmetic with it. Break this up into a right triangle and understand that cosine affects the horizontal length and sine affects the vertical length. 8 is my scalar if referred to the unit circle, and so my horizontal component is 4√3, 4. Last thing I'd like to look at, if I'm given a component form, how would we determine the magnitude and the direction? Once again, making a right triangle out of the vector, the hypotenuse of the vector is also going to be the magnitude. So Pythagorean theorem will get me the magnitude, 4√5, or approximately 8.944. To get the angle, first I'm going to calculate the angle on the inside of the triangle, called the reference angle, and this would give me -63.43, but I'd like to always measure from the positive horizontal axis. Subtracting this from 180 gives me an angle of 116.57 degrees from the horizontal. So in this video you've gotten a better understanding of how they can be represented with component form and magnitude and direction.